In this video, I will show you how to use a candidates test to find the absolute extrema. That means the absolute maximum and absolute minimum on the interval given. The first step is to find the derivative. So y prime equals. We're going to have to use the chain rule, starting with the outer function of tangent. We know that the derivative of tangent is secant squared. So we have secant squared of stuff. And here's where the chain rule comes in. Because we have another function on the inside, we have to multiply by the derivative of that function. So this is going to just be pi over 8, which is the constant in front of the x. So this is the derivative. In a moment, we will need to find the critical numbers, but for that, it's best if we write this as a fraction. So remember that secant is the reciprocal of cosine. So we can write this as 1 over cosine squared, pi x over 8, times pi over 8. I'm just going to put even this into a single fraction, multiplying straight across. Now it's time to find the critical numbers that make y prime equal to 0 or undefined. Y prime will equal 0 when the numerator is equal to 0, but the numerator is a constant, so there aren't any values that will cause y prime to equal 0. To make y prime undefined, the denominator has to equal 0. So let's set the denominator equal to 0 and solve for those critical numbers. Dividing both sides by 8, we get cosine squared pi x over 8 is equal to 0. Taking the square root of both sides, we get cosine pi x over 8 is equal to 0. We need to solve this for pi x over 8. So cosine of what will equal 0? Cosine is an x value, so it will equal 0 here and here. So that means pi x over 8 will equal pi over 2, and pi x over 8 will equal 3 pi over 2. So let's just solve both of these little equations. To solve this first equation, let's multiply both sides by the reciprocal. Let's multiply by 8 over pi on each side, 8 over pi. In fact, it'll be the same thing on this next one, so might as well do it again. 8 over pi on the left side, 8 over pi on the right-hand side. So you can see the pi's and the 8's will cancel out. So that's going to leave you with x equals. On the right-hand side, the pi's cancel out, so you just have 8 divided by 2, which is 4. So there's one solution. And then over here, again, the pi's and 8's cancel each other out, so you just have x equals. On the right-hand side, the pi's cancel each other out, so you have 8 divided by 2, which is 4, and then 4 times 3 is 12. But here's the thing. We're given an interval, a domain of 0 to 2. These values are outside of the domain, so they cannot be used. It's time to set up the candidates test. Make sure you label it using the words candidates test. Normally, the x values of the candidates test would be the critical numbers and the endpoints. Since our critical numbers were both outside the domain, then we will just use the endpoints. So our x values will be 0 and 2. We will evaluate the original function at each of these candidates, and whatever is the highest value, that will be the absolute max. The lowest value will be the absolute min. Let's start with the x value of 0. So we have tangent of pi 0 over 8. Well, pi 0 over 8 is just 0. So that means we're just evaluating tangent of 0. Remember that tangent is sine over cosine, so this would be the same as sine of 0 over cosine of 0. Well, sine of 0 is 0. So this is 0 over, and cosine of 0 is 1. So tangent of 0 is 0. At an x value of 2, we have tangent of pi 2 over 8, or 2 pi over 8. But 2 and 8 reduce, so this is really pi over 4. So what is the tangent of pi over 4? Hopefully you memorized this is 1. So 1 is the absolute maximum, and 0 is the absolute minimum. Let's go ahead and write up the answer. Here's how you would write up your final answer on the AP exam. On the interval from 0 to 2, y equals tangent of pi x over 8 has an absolute maximum of 1 at x equals 2. Y equals tangent pi x over 8 has an absolute minimum of 0 at x equals 0. See candidates test. This last statement is your justification. Make sure you include it. And this is why we had to label the candidates test as such. Number 40 is interesting because we will find the absolute maximum and minimum of the same function for slightly different intervals. So we need to start by finding the derivative, but even before we do that, let's rewrite the function slightly as 4 minus x squared to the 1/2 power. So now we can take the derivative using the chain rule. So first we will take the derivative of the outer function by putting the 1/2 in the front. We need to subtract 1 from this, so we're subtracting 2 over 2, so this will be negative 1/2 power. But then we've got this inner function, 4 minus x squared. So the chain rule says we have to multiply by the derivative of the inner function. That's going to be negative 2x. So this is the derivative. We need to clean it up a little bit, make it more useful. For starters, these 2's are going to cancel each other out. That will still leave negative x. So I'm going to have a negative x in the numerator. I'm going to drop the 4 minus x squared to the negative 1/2 power down to the denominator, and I'm also going to put it back as a square root. So this is the square root of 4 minus x squared. It's time to find the critical numbers that will cause f prime to either equal 0 or be undefined. The fraction will equal 0 when the numerator is equal to 0, which would mean x equals 0 is our first critical number. F prime will be undefined when the denominator is equal to 0. That will happen when 4 minus x squared is equal to 0. I think I will add x squared to both sides, so this will be 4 equals x squared. Taking the square root of both sides, we have plus or minus 2 is equal to x. So these are two additional critical numbers, x equals 2 and x equals negative 2. So in a moment, we will be setting up a candidates test for each of these intervals. The x values on the candidates test will include these 3 critical numbers plus the endpoints of the interval. Let's go ahead and set up the first candidates test using these 5 x values. Wait, did I say 5 candidates? There are only 3. I didn't notice at first that the endpoints are the same as 2 of the values from our critical numbers. So let's evaluate each one of these. Let's evaluate the function at each one of these. The highest value will be the absolute maximum, and the lowest value will be the absolute minimum. 4 minus negative 2 squared, this is just 4 minus 4, so that's going to be 0. The square root of 4 minus 0 squared is just the square root of 4, so that's 2. 4 minus 2 squared is 4 minus 4, so that's 0 again. Before we do anything else, let's put brackets on the endpoints to show that the endpoints are included. That's going to be important as we compare to other intervals. Sometimes the endpoints are not included and therefore cannot be a location of a max or a min. But in this case, the highest value is 2. So we have an absolute max at 0, which is 2. We have an absolute minimum of 0, and it is at 2 locations, which is interesting but not unheard of. So here's how you would write up your final answer on the AP exam. On the interval from -2 to +2, f of x has an absolute maximum of 2 at x equals 0. F of x has an absolute minimum of 0 at x equals -2 and x equals +2. C, candidates test. For part B, I have so far copied the candidates test from part A. I want to modify it to fit this interval that we're given. So for starters, this interval only goes from -2 to 0. That means that +2 will not be included. So I'm just going to erase this part of it. And 0 itself is not to be included either. So I'm going to put this here. So now let's interpret the results. The highest value is 2. However, that came from the value that's not included in the interval. So there will be no max, no absolute max. The lowest value is 0. So we do have an absolute min of 0 at an x value of -2. So here's how you would write up your answer on the AP exam. On the interval from -2 to 0, f of x has no absolute maximum. F of x has an absolute minimum of 0 at x equals -2. C, candidates test. This is the candidates test cut and pasted from part A. Let's just make modifications so that it fits the interval given in part C. The only difference is parentheses. So I'm going to take away these brackets and replace them with parentheses to show that these particular endpoints are not to be included. So this cannot be included and this cannot be included as the source of an absolute max or min. So the highest value is still 2. So we still have an absolute max here. But the lowest value of 0 occurs at these endpoints which are not to be included. So that means we have no absolute min. Just for fun, take a look at this graph on Desmos. So you can see that we have the absolute maximum of 2 right at 0. But because the endpoints are not to be included, the points at the bottom are open circles. So there is no absolute minimum. So here's how you would write up your answer on the AP exam. On the interval from -2 to +2, f of x has an absolute maximum of 2 at x equals 0. F of x has no absolute minimum. C, candidates test. Once again, here is the candidates test from part A. I need to modify this so it fits the interval given to us here in part D. For starters, this interval only goes from 1 to 2. So that actually leaves out both of our first two values from this candidates test. So I'm going to erase both of these. But we've got a new value that we haven't used before. This value of 1 needs to be tested. While I'm here, I'm going to change this bracket to a parenthesis to show that it is not to be included. If it turns out to be the highest value or the lowest value, it will not count as a max or a min. So we need to evaluate at 1. So we have the square root of 4 minus 1 squared. So that's going to be the square root of 3. So the square root of 3 is the absolute maximum value. However, the lowest value is 0, but it occurs at an x value that is not to be included. Therefore, there is no absolute minimum. Here's how this looks on Desmos. So you can see that we have an absolute max at square root of 3, but because the right endpoint is not to be included, the bottom value is an open circle, so there is no absolute min. Here's how you would write up your answer on the AP exam. On the interval from 1 to 2, f of x has an absolute max of radical 3 at x equals 1. F of x has no absolute min. See Candidate's test. Determine from the graph whether f has a minimum in the open interval from a to b. Open interval means those endpoints are not included. You can tell because of the open circles as well. So look at graph A. Does this have an absolute minimum? Yes, it does, because the low value is a closed circle, so there will be a minimum right here. What about graph B? Does this have a minimum? No, this does not have a minimum because there's an open circle at the low point, which is not to be included. So that's why this is a no. New picture for number 56. How about graph A? Does this have an absolute minimum? Nope, this does not have a minimum because, again, we have an open circle at what would be the lowest point, but this is not included. What about graph B? Does this have a minimum? It sure does, because at the low point we have a closed circle and that will be the absolute minimum.